Hey there, and welcome back to the show. You know that feeling when you're using ChatGPT or Claude or Gemini and you realize that everything you type gets sent to some server far away? Someone else's computer is doing all the thinking for you? And yeah, it works great, but there is this tiny voice in the back of your head wondering what happens to your data. Or maybe you have that sinking feeling every month when the API bill arrives. Or you are on a flight with no internet and you just wish your laptop could handle the heavy lifting itself. Well, good news, that future is not just possible. It is already here and it is way more accessible than you think. Welcome to the world of local AI. I am Zoe, and in this episode, we are going to talk about something that I think is one of the most exciting shifts happening in tech right now, running powerful AI models on your own hardware. No cloud, no subscription, no data leaving your machine. Just you and a genuinely smart model running right there on your laptop or desktop. Sounds like science fiction from just a couple of years ago, right? Well, it is not. It is real, it is practical, and I am going to show you exactly how it works. Here's what we are going to cover today. First, I want to talk about why local AI matters right now in 2026 and why the timing has never been better. Then we will dive into the hardware you actually need, and I promise it is less intimidating than you think. After that, I will walk you through the software tools that make all of this possible. Tools like Ollama and LM Studio and Llama.cpp. And then we will talk about which models you should actually run, because not all models are created equal, and the landscape has changed dramatically in just the last few months. Finally, I will give you a practical step-by-step guide to get started in less than 15 minutes. Sound good? Let us jump in. So why local AI and why now? Let me paint you a picture. 2 years ago, if you wanted to run a large language model on your own computer, you were looking at serious compromises. The models were small, the output quality was frankly not great, and you basically needed to be a command line wizard to get anything working. The ecosystem was held together by forum posts and GitHub issues. It was a hobbyist thing, and honestly, most people gave up after the first failed install. Fast forward to mid 2026, and the picture could not be more different. The open weight model landscape has exploded. And when I say open weight, I mean models where the actual trained parameters, the brain of the AI, are publicly available for anyone to download and run. Companies like Alibaba with their Qwen family, Meta with their Llama models, Google with Gemma, Mistral from France, DeepSeek from China, they are all releasing models that rival the quality of the best cloud services. And these are not toy models. We are talking about models that score competitive with GPT-4 on reasoning benchmarks. Models that can write production-level code, analyze documents, help you with research, and hold genuinely intelligent conversations. All running on a machine that sits on your desk, the numbers are kind of staggering. A model like Qwen 3.6 with 27 billion parameters, which is basically the current champion for consumer hardware in terms of quality, can fit comfortably on a single graphics card with 24 gigabytes of VRAM. That is a used RTX 3090 that you can find for around $600. Or even better, the new Mac Mini with an M4 Pro chip and 48 gigabytes of unified memory can run models that would have required a server rack just 18 months ago. We have reached this critical tipping point where the hardware you probably already own or could buy for a reasonable price is powerful enough to run genuinely useful AI. And the benefits of running locally are huge. First and most obvious, privacy. When you run a model locally, your data never leaves your machine. Every prompt, every document you upload, every conversation stays right where it belongs. For anyone working with sensitive information, client data, proprietary code, or personal stuff you just do not want floating around on someone else's servers, this is a game changer. Second, a local setup is a one-time hardware investment. After that, inference is free. You can ask a million questions, and the only cost is the electricity to power your machine. Third, no rate limits. Ever been throttled by a cloud service because you asked too many questions? That does not happen locally. You can go as hard as you want. Fourth, offline access. No internet needed. You can be on a plane, in a cabin in the woods, or in a secure facility with no external connectivity, and your AI works exactly the same. So, the why is pretty compelling. Now, let us talk about the hardware. And I know this is where a lot of people get nervous, so let me demystify it for you. There are basically three paths you can take to run local AI, and each one works for different situations and budgets. Path number one is CPU only. Yes, you read that right. You do not need a fancy graphics card at all. If you have a reasonably modern processor with at least 16 gigabytes of RAM, you can run small language models right now. Models in the 3 to 8 billion parameter range run perfectly fine on CPU alone. The speed will not blow your mind. You're looking at maybe 10 to 25 tokens per second depending on your processor, but for chat and simple tasks, that is perfectly usable. Reading speed is about 10 to 15 tokens per second for most people, so anything above that feels responsive. A lot of people do not realize this, but the entire local AI revolution works without a GPU. A machine like the Beelink EQR6 mini PC, which costs around $400 and has 32 gigabytes of RAM, can run a solid 7 billion parameter model 24/7. Quietly sipping power on your shelf. You can use it as your own private AI server that every device on your home network can talk to. That is wild when you think about it. Path number two is the GPU route. This is where things get really interesting. The single most important factor for local AI performance is not the clock speed of your processor or how many cores you have. It is VRAM, video RAM on your graphics card, and more specifically, the memory bandwidth of that card. Here's why. When a model generates text, it has to read its weights, all billions of them, from memory for every single token it produces. The faster it can read those weights, the faster the model responds. So a card like the RTX 4090 with its 1000 gigabytes per second of memory bandwidth generates text about 15 times faster than system DDR5 RAM. The GPU route is for people who want the best performance without spending enterprise money. So what are the sweet spots in 2020-26? If you have 8 gigabytes of VRAM, you can run 7 to 8 billion parameter models at 4-bit quantization, which is a compression technique I will explain in a moment. Models like Llama 3.1 8B or Mistral 7B work great. 12 gigabytes gets you into 13 billion parameter model territory. 16 gigabytes, which you get on cards like the RTX 4060 Ti 16 GB, lets you run 20 to 30 billion parameter models. And 24 gigabytes, the magic number, which you can get on a used RTX 3090 for around $600 or a new RTX 4090, lets you run the real heavy hitters. 40 to 70 billion parameter models at good quality, the RTX 3090 on the used market is honestly the best value in local AI right now. It is the card I recommend to almost everyone who asks. Path number three is Apple Silicon, and this is where Apple has an interesting advantage. Macs with M series chips use something called unified memory, where the RAM is shared between the CPU and GPU. That means if you get a Mac with 64 gigabytes of unified memory, the GPU can access all 64 gigabytes for model weights. Compare that to a typical PC where even a high-end RTX 4090 only has 24 gigabytes of VRAM, and you see the difference. A Mac Studio with an M4 Ultra and 192 gigabytes of unified memory can run unquantized 70 billion parameter models. Slowly, but it can do it. For most people, a Mac Mini M4 Pro with 48 gigabytes is the sweet spot. You get to run models that would not fit on any consumer GPU, and the memory bandwidth on Apple Silicon is genuinely impressive. Now let me explain quantization, because it is probably the single most important concept in making local AI work on consumer hardware. And it is simpler than it sounds. Imagine you have a high-resolution photograph that takes up 100 megabytes on your hard drive. You want to send it to a friend, but their internet is slow, so you compress it down to a JPEG. The image loses a tiny bit of quality, but it is still perfectly recognizable, and it is now only 10 megabytes. Quantization works exactly the same way for AI models. AI models are traditionally stored using 32-bit or 16-bit floating point numbers for their weights. Each weight is a very precise decimal number. Quantization reduces the precision of those numbers. Instead of a 16-bit number, you use a 4-bit or 8-bit number. The model becomes smaller, much smaller, and it runs faster because there is less data to move around, but it retains most of its intelligence. A 4-bit quantized model typically retains over 99% of the original's capability, while being a quarter of the size. This is why you can run a 70 billion parameter model that would normally require 140 gigabytes of VRAM on a 24 gigabyte card. You just compress it down. The most common quantization format is called GGUF, which stands for GPT-Generated Unified Format, but honestly, do not worry about the acronym. Just know that GGU files are the standard for local AI, and they come in different quality levels. QA is near perfect quality, but larger. Q4 is the most popular balance of size and quality, and Q2 is maximum compression with some quality loss. Most people use Q4 and are very happy with the results. Now let us talk about the software that makes all of this actually usable. And I am happy to report that in 2026, the tooling has matured to the point where you do not need to be a developer to get started. The ecosystem has consolidated around a few key players. The first and most important tool is Ollama. Think of Ollama as the app store for local AI. It is a free, open source tool that handles downloading models, running them, and exposing them as an API. The experience is incredibly smooth. You install Ollama, open your terminal, type something like Ollama Polquan 3, and within minutes, you are chatting with a powerful model right on your machine. As of July 2026, Ollama is at version 0.32.2. And it just keeps getting better. The latest releases have added an interactive agent mode where you can chat, write code, and even let the model browse the web. There's a skills system now, better model caching, and support for more models than ever. And Ollama works on macOS, Windows, and Linux. It has become the de facto standard for local AI, and for good reason. The second tool worth knowing is LM Studio. If you prefer a graphical interface over the command line, LM Studio is for you. It is a desktop app with a beautiful interface where you can browse models, download them with one click, and chat with them. It is especially great for what I call model shopping, testing different models side by side to see which one works best for your specific needs before you commit to anything. LM Studio also bundles everything you need under the hood, so you do not have to worry about installing separate dependencies. It just works. The third tool is llama.cpp. This is the engine that actually powers most of the other tools. Ollama and LM Studio both use llama.cpp under the hood to do the actual computation. Some power users prefer to use llama.cpp directly because it gives you full control over every parameter. You can tweak the number of layers offloaded to the GPU, adjust the thread count, customize your quantization scheme, and squeeze every last drop of performance out of your hardware. But for most people, the wrappers like Ollama are the way to go. There's also MLX, which is Apple's own machine learning framework, and it is specifically optimized for Apple Silicon. In recent updates, MLX got support for the M5 neural accelerators, which gives up to 4 times faster performance on the latest Macs. Both Ollama and LM Studio now use MLX as their backend on Apple Silicon, which means Mac users are getting great performance without any extra configuration. So now you have the hardware and the software. What model should you actually run? This is where it gets fun because there have been so many great releases recently. If you have a 24GB graphics card, the model you want right now is Qwen 3.6 with 27 billion parameters. It is the best all-rounder for consumer hardware in July 2026. It scores extremely high on coding benchmarks, it handles reasoning tasks well, it supports tool calling, and it fits in about 17 gigabytes at 4-bit quantization. That leaves you room for context, so you can have long conversations without running out of memory. For coding specifically, there is also Kimi K2.6 from Moonshot AI and Laguna XS 2.1 from Poolside, both of which are excellent for agentic coding workflows, where the model needs to write and debug code autonomously. If you have less VRAM, say 16 gigabytes, do not worry. The new Gemma 4 models from Google are fantastic. The 12 billion parameter version runs in about 8 gigabytes and punches way above its weight class in terms of quality. It is great for general chat, document analysis, and tool use. There is also Mistral Small 3 from the French company Mistral AI, which is efficient, fast, and has a permissive license that makes it great for commercial use. If you are running on CPU only or with very limited hardware, models like 5.4 from Microsoft with 14 billion parameters at 4-bit quantization run well on just 8 gigabytes of RAM, and if you want the absolute best reasoning capabilities, DeepSeek R1 is available in various sizes all the way down to 1.5 billion parameters. It uses chain-of-thought reasoning, meaning it thinks step by step before answering, which gives it remarkable problem-solving ability even in the smaller sizes. And here's a pro tip. You're not limited to just one model. With Ollama, you can download multiple models and switch between them depending on what you are doing. Use a small, fast model like Gemma 412B for everyday chat, switch to Qwen 3.627B for serious coding work, and use DeepSeek R1 for complex reasoning tasks, all on the same machine. So let me walk you through exactly how to get started, because the best way to understand this is to actually do it. First, go to the Ollama website and download the installer for your operating system. It takes about 30 seconds to install. Once it is done, open your terminal. On Windows, you will use PowerShell. On Mac, it is the terminal app. On Linux, you probably already know what to do. Type Ollama, pull Gemma 412B, and hit Enter. Ollama will download the model, which is a few gigabytes, so it might take a few minutes depending on your internet speed. When it is done, type Ollama run Gemma 412B. And just like that, you are chatting with a powerful language model running entirely on your machine. No internet required, no subscription, no data leaving your computer. You can ask it to write a blog post, help you debug some code, summarize a document, explain a complex topic, or just have a conversation. And the best part is, it is completely private. Everything you type stays on your machine. If you want a more polished experience, download LM Studio. It gives you a graphical interface where you can browse models, see how much RAM they need before you download them, and chat in a clean interface. It is especially good if you are new to this and prefer a visual approach. Once you have your first model running, you can start exploring more advanced setups. You can install Open Web UI, which gives you a ChatGPT-style web interface that connects to your local Ollama instance. You can set up a local AI server on a mini PC and access it from your laptop, phone, and tablet across your home network. You can connect your local models to coding tools like VS Code through extensions like Continue, which lets you use a local model as your AI coding assistant instead of GitHub Copilot. You can build Retrieval Augmented Generation Systems, or AGA, where your local AI can search through your own documents and answer questions based on your private data. The possibilities are genuinely endless. Let me give you some concrete examples of what you can actually do with local AI in 2026. Imagine you are a freelance writer working on a sensitive article about a controversial topic. You do not want your research prompts and drafts floating around on some company's servers. You fire up your local model, load your research notes into the context, and start drafting. The model helps you structure your arguments, suggest alternative phrasings, fact checks your claims against the documents you loaded. All of it stays on your laptop. No data ever leaves your machine. Or imagine you are a developer working on proprietary code for a client under a strict NDA. You cannot use GitHub Copilot because the code cannot be sent to Microsoft servers. You fire up Ollama with Qwen 3.6, open VS Code with the Continue extension, and you have a coding assistant that understands your entire code base and never sends a single line of code to the cloud. It auto-completes functions, suggests refactors, writes tests, and debugs issues all locally. Or maybe you are a student researching a paper. You download a batch of PDFs, use a local model to summarize each one, then ask it to synthesize the key themes across all the documents. You can have a conversation with your research library, asking questions and getting answers grounded in the actual documents you provided. No subscription fees, no data leaving your machine, and you can work from anywhere, including the library basement with no Wi-Fi. And here is something really cool. You can run local AI models to power smart home automation. Set up a local model on a mini PC that acts as your home brain. It can process voice commands, manage your calendar, control your smart lights, and answer questions about your schedule, all without any data ever leaving your home network. No cloud dependency, no privacy concerns, no monthly fee. Now let me address some common concerns and questions, because I know some of you might be thinking about the downsides. First, is local AI as good as cloud AI? The honest answer is, for most everyday tasks, yes, the gap has closed dramatically. Models like Qwen 3.627B and Gemma 4 are genuinely competitive with GPT-4 for many tasks. But if you need the absolute frontier of AI capability, the very best reasoning, the most creative writing, the longest context windows, the cloud still wins. Cloud providers can run massive models with hundreds of billions of parameters that simply do not fit on consumer hardware. So think of local AI as your daily driver for most tasks, and use the cloud when you need that extra oomph for something really challenging. Second, how much does this cost? If you already have a decent computer, the software is completely free. Ollama, LM Studio, llama.cpp. All the tools are open source and free to use. The models are free to download. Your only cost is the hardware. If you are starting from scratch, you can get a mini PC with 32 gigabytes of RAM for around $400 that will run capable models. A proper desktop with a used RTX 3090 will cost you around $1,200 to $1,500 total. Compare that to 2 years of ChatGPT Plus at $20 a month, which is almost $500, and you are paying for a service where you never own anything and your data leaves your machine every time. The local option pays for itself surprisingly fast if you use AI regularly. Third, is it hard to set up? Not anymore. The Ollama install process takes less than 5 minutes. Download, install, open terminal, pull a model, run it. That is it. You do not need to understand how neural networks work, or how quantization works, or how inference engines work. The tools handle all of that complexity for you. You just use the AI. Fourth, what about updates? Models are being released at an incredible pace. In just the last few weeks, we have seen Ollama go from version 0.3D to 0.32 with major new features. New models are added to the Ollama library almost daily. The community on Reddit and Hugging Face is incredibly active. If you want to stay current, just run Ollama poll with a new model name every few weeks and you will have access to the latest and greatest. Let me give you a quick update on what has happened just recently in the local AI world, because the pace of change is honestly breathtaking. In the last few days, Ollama released version 0.32.2 with a new skill system for AI agents, better code generation capabilities, and improvements to how models handle tool calling. New models like Laguna XS 2.1 for agentic coding and Kimi K2.7 code have been added to the library. Google's Gemma 4 models got significant speed improvements on Apple Silicon, running about 90% faster than before. The MLX framework added support for the new M5 neural accelerators, giving Mac users up to 4 times faster performance on certain workloads. And the llama.cpp engine merged support for multi-token prediction, which speeds up generation by 1.5 to 3 times on supported models without needing a separate draft model. All of this happened in the last few weeks. The ecosystem is moving incredibly fast, and it is only getting better. Local AI in 2026 is not about sacrificing quality for privacy anymore. It is about having a genuinely capable AI assistant that lives on your hardware, respects your privacy, costs you nothing to run, and works even when you are offline. The technology has crossed the threshold from hobbyist curiosity to legitimate everyday tool. Whether you are a developer, a writer, a student, a researcher, or just someone who cares about their digital privacy, there has never been a better time to run AI locally. The best part is, you can start right now. While you are listening to this episode, you can go to the Ollama website, download the installer, and by the time this podcast is over, you will have your own private AI running on your machine. No credit card required, no data sharing agreement, no subscription. Just you and a genuinely intelligent model, completely under your control. So here is my challenge to you. Try it this week. Install Ollama, pull a model. Ask it something that matters to you. See how it feels to have an AI that is truly yours. I think you will be surprised by how far this technology has come. Let me wrap up with a quick summary of what we covered today. Local AI means running models on your own hardware instead of sending data to the cloud. The benefits are privacy, zero ongoing cost, no rate limits, and offline access. You can run local AI on CPU only, on a GPU, or on Apple Silicon. The most important hardware factor is VRAM for GPUs or unified memory for Macs. Quantization compresses models so they fit on consumer hardware while retaining most of their quality. Ollama is the easiest way to get started, with LM Studio as a great graphical alternative. The best models right now include Qwen 3.627B for general use, Gemma 4 for smaller setups, and DeepSeek R1 for reasoning. And getting started takes less than 15 minutes. The future of AI is not just in the cloud, it is on your desk, in your laptop, in your pocket. It is yours. And honestly, I think that is the way it should be. Thank you so much for listening to this episode. If you found it helpful, I would really appreciate it if you share it with a friend who might be curious about running AI locally. And if you want to stay up to date with the latest tools, models, and tips, make sure to subscribe so you never miss an episode. Until next time, keep experimenting, keep building, and keep your data where it belongs. This is Zoe signing off.